Okay, here's the second part of that problem. In the first part of this problem, that we found that the guy has to pull with a force of 520 newtons in order to get the 470 newtons to overcome the force of friction. And so in this one, I went ahead and I underlined all the givens and the unknowns that we need to solve 1 and 2. Okay, so the load has moved a horizontal distance of 2.5 kilometers in 1.2 hours. Okay, so first thing that we need to do here, 2-point question here, we need to calculate the work done on the load by force F. Okay, so the work done is force times displacement. Okay, so I'm gonna actually I gotta go to full UI. Let's see here. Yeah, and put that there. I want to do this in red here. Okay, so for my evaluate part, okay, they're asking me to find the work done. So I'd go to my data booklet and I look for the equation for work. Work equals sorry, that's kind of hard to read. Work, all right. Work equals force times displacement. Okay, work equals Fs. All right. Actually, in the equation packet, it'll look like Fs cosine theta. Okay. In this case, theta is 0 degrees. And if you take the cosine of 0 degrees, you end up with 1. So cosine of theta is just equal to 1. It doesn't really do anything to our equation here. All right. So first thing we need to do here is we need to calculate this displacement. And they said distance, but we'll assume he's moving in a straight line. So the distance is equal to the displacement. Okay, so 2.5 kilometers, and I have to convert that into meters. All right, and I know that's an easy conversion, but I want to show you how to do it here. 2.5 km times, we're going to do some dimensional analysis, times 1,000 meters divided by 1 kilometer. The reason that I'm showing you this is just because I want to see, I want to show you exactly how it should be done correctly. I know that most of you guys can do this in your heads, but this way you can show the units canceling out. All right, but it's not necessary to do it. All right, work is equal to force times displacement. When I calculate this out, I end up with 2,500 meters. Okay, so that's a 0 there. 2,500 meters. All right. So I got I have my force in the horizontal direction. That was 470 newtons, and I should have written that in blue, but I didn't. So 470 newton force. That was a given as well. Okay. So work equals 470 newtons. Here, F. Force equals 470 newtons. 470 newtons times 2,500 meters. Okay. This equals 1.2 times 10 to the 6th joules, or 1.2 megajoules, because mega is 10 to the 6th. Okay, so we got the energy required. Okay, next part of the problem, they want us to calculate the average power required to move the load. All right. Oh, I forgot. This was my solve step. It's only my second video, so I missed it. And the sentence would be the work done on the load is 1.2 megajoules. All right. Next step, the power required to move the load. Okay, so I'm going to have to use my answer from above. That's one of my givens now. All right, I'm going to evaluate this one here. Okay, so power is equal to the work done per unit of time. It's also equal to the force times the velocity. Okay, I'm going to solve this using the work divided by time, and I'm going to let you do the force times velocity. Okay, so the work done is 1.2 megajoules, but the time they gave it to us in hours, so I have to convert that to seconds. So what I need to do is dimensional analysis here. And this is one where it might be helpful to actually do the dimensional analysis, even though it takes a little while to write it out. 1.2 hours, I should have left some room there for the H. 1.2 hours times 60 minutes divided by 1 hour. Okay, cross out hours here, times 60 seconds in a minute. Okay. What I end up with here when I calculate this out, and I want to make sure I cross them out, okay, left with seconds, I'm left with 4.32 times 10 to the third seconds. Okay. So I have my time and the work done. Okay. So now what I do is I take the work and I divide it by time. So I have 1. So this is my solve step. Okay. I have 1.2 times 10 to the 6th joules. I'm going to convert it back to joules because power is actually joules per second, which is watts. Okay. So 1.2 megajoules is 1.2 times 10 to the 6th joules, divided by 4.32 times 10 to the 3rd seconds. Okay. Notice I have joules divided by seconds here, so I know as long as the magnitude of my values here is correct, the units are obviously right. All right, calculate that out. Maybe you might want to stop the video and do it yourself. All right, I'm going to go ahead and this equals 283 watts. Okay, the answer that they had was about 270, and when I solved it using the force times velocity, I actually got 270 watts. You could also write this as 283 joules per second. I would accept that as an answer. Okay, a watt is a joule second. All right, what that means is it's power is a rate. It's the amount of energy per second or the amount of work done per second. All right. So to solve this, to write a sentence for this, I would say that the minimum average power required to move the load is 283 watts. All right. For C, okay, explain in terms of the energy changes why the minimum average power required is greater than in B. And this guy, at this point, he's pulling the load uphill. The reason that it's greater is because he's got to fight gravity because he's going uphill, and work is still done against friction. All right, so that is the end of problem number 1. See you later.